Hey guys, so number 3 is a probability problem. It says approximately 3.5% of all children born in a certain region are from multiple births. That means twins, triplets, etc. Of the children born in the region who are from multiple births, 22% are left-handed, and of those born who are from single births, 11% are left-handed. So question A says, what is the probability that any randomly selected child in the region is left-handed? So really, that means we have to think about, well, the children who are from multiple birth and left-handed and from single birth and left-handed. We're going to have to add those together since those are mutually exclusive. So first thing I'm going to do, I'm going to write down some information here. So the probability of having multiple births is 0.035, which means the probability of a single birth or not multiple birth, 0.965. And they also tell us the probability that you are left-handed given that you are a twin or something, 0.22, and they tell us left-handed given that you're not from multiple birth, they tell you that's 0.11. So it kind of looks like you're more likely to be lefty if you're not from multiple birth, but we'll go from, in a second we'll talk about that. So now I'm going to make myself a little diagram here, right? So the probability of being multiple, 0.035. And the probability of not multiple, or single birth, 0.965. And they tell us that if you're from a multiple birth, right, you're going to be lefty, 0.22, which means not lefty or righty, 0.78. You also have, if you're a single birth and your probability is going to be lefty is going to be 0.11, and the probability of righty or not lefty, 0.89. Now, do we need all of these different branches? No, we don't. We just want to know, for part A, what is the probability of being lefty? Any kid in this region is lefty. Well, that's going to be the probability that you are from a multiple birth and lefty, plus from a single birth, or not multiple, and lefty. So what are those probabilities? Well, we could just really add together 1, 2 branches, right? So what is the probability of multiple and lefty? Well, that's just going to be 0.035 times 0.22, which is 0.0077, plus 0.965 times 0.11 is going to be 0.10615. So what is the probability that any given child is lefty? You're going to add those up. You're going to get 0.11385. Okay. Now, part B. What is the probability that a randomly selected child born in the region is a child from a multiple birth, given that the child selected is left-handed? So part B question, I'm just going to kind of box this work off for a second, is going to say they're looking for a probability that given that they're lefty, what's the probability that they are from multiple birth? Or in other words, what percentage of the 11% is lefty? Oh, sorry, are from multiple births. So if we go to our reference sheet, we have A, we have B, and it says it's the probability of A and B over B, which in this case is the probability of lefty and multiple birth over multiple birth. Did I write this backwards? What is the probability that a randomly selected child born in the region, given that the child selected is left-handed, given that they're, oh, I wrote it backwards. Apologize. So that's going to be given that they're left-handed. It's probability of multiple birth. So out of the 11.385, what proportion are going to be from the multiple birth? Well, that's probability of A and B, but we did that already. Multiple birth and lefty, we did that right here. It's 0.0077. It's because most of the kids who are lefty come from non-multiple births. And that tells us for part B, we get approximately 0.0676. And one more part, we have part C. I'm just going to branch this off here. Part C says, a random sample of 20 children born in the region will be selected. What is the probability that the sample will have at least 3 children who are left-handed? So they're saying, what's the probability that 3 or more lefty out of 20? And we just saw this on 2019. Out of 20 is a set number of trials. This is a binomial distribution. Binomial distribution. Right? How do we know? Set number of trials. So what are they looking for here? Well, this should be pretty fresh in our minds. 3 or more, we can't do that in the calculator. You don't want to do binomial PDF for 4, 5, 6, 7, 8, all the way up to 20. So instead, we do 1 minus the probability of 2 or less lefty. So that's 1 minus, and this comes out to 0.59785. Now, how did I do that? Don't put your calculator talk, but the way I got this, binomial CDF, right? You're going to put trials, you're going to put 20, you're going to put your probability of being lefty. Well, the probability of being lefty is 0.11385. Right, that's from earlier on, part A, and you're going to put x value as 2. And that tells us that the probability of getting 3 or more lefty kids if you pick 20 is about 0.4021.